Hello everyone, I am Deepak Gupta. Welcome to ZT classes. Today we'll discuss few proving questions from our chapter Some Application of Trigonometry. Take our question. So the angle of elevation of the top of a tower from 2 points distant S and T from its foot are complementary. So we have got a tower is there. Now from this tower there are 2 points are there which are at distance of S and T, and from there the angle of elevation is complementary. So let's say those 2 points are Q and P, they are at distance of S and T. From point Q, let's say the angle of elevation is theta degrees. Now from P, the angle of elevation is complementary, that is that angle will be 90 minus theta. We have to prove that the height of tower is square root of S into T. Let's see the solution. So here in this question it's given that AB is a tower and P and Q are the points of observation. Let the angle APB is 90 minus theta and angle AQB is theta. So to prove, we have to prove height of tower, that is AB, is equals to square root of S into T. Let's see the proof. बेटा like all other questions है ना जो हमने पहले भी किए हैं, तो हर क्वेश्चन में कहानी वही है कि आपके पास दो राइट एंगल ट्राइंगल होंगे, उन दोनों को आपको सॉल्व करना है और उन दोनों में ट्रिग्नोमेट्रिक रेशियोज लेनी है. कौन सी रेशियो लेंगे? 90% क्वेश्चन में आप 10 की रेशियो लगेगी, है ना. अदरवाइज यू कैन वर्कआउट इजली हियर कि आपको जो साइड गिवन है और जो फाइंड करनी है वो रेशियो में इंक्लूड होनी चाहिए. गिवन आपको यहाँ पर क्यू बी है और फाइंड आपको ए बी करना है, तो कौन सी रेशियो लगाएंगे? 10 की रेशियो. ठीक है, तो लेट्स सी हियर. सो वी आर टेकिंग, सबसे पहले हम ट्राइंगल कौन सा ले रहे हैं? ट्राइंगल ए बी क्यू. तो tan थीटा इज इक्वल्स टू ए बी अपॉन क्यू बी. तो यहाँ पर हम क्यू बी की वैल्यू डालेंगे s. सो विल गेट tan थीटा इज ए बी अपॉन s. तो सेम वे सेकेंड ट्राइंगल कौन सा होगा बेटा? ए पी बी. सो लेट्स टेक ट्राइंगल ए बी पी. सो अगेन विल टेक tan. So tan 90 minus theta is AB upon PB, that's perpendicular upon base. Tan 90 minus theta is nothing but cot theta and PB is given as T. तो यहाँ पर अब एक इंटरेस्टिंग बात जो आई है कि यहाँ पर tan थीटा है, ये cot थीटा है, और जो हमारा आंसर है टू प्रूव में हमें थीटा को बेसिकली एलिमिनेट करना है. तो हम क्या करें? इन दोनों इक्वेशंस को हम मल्टीप्लाई कर देते हैं. तो tan थीटा इंटू कॉट थीटा हमें पता है 1 होता है ना. विल गेट आवर आंसर. सो वी आर मल्टीप्लाइंग बोथ द इक्वेशंस, रिप्लेसिंग tan थीटा इंटू कॉट थीटा बाय 1. सो विल गेट ab square 1 is equals to ab square upon st. On simplifying you will get ab as square root of st, and the height of tower is square root of st, and hence proved, we have proved that height of tower is square root of st. Let's see our next proving question. So we have been given a vertical tower stands on a horizontal plane. So we have got a vertical tower standing on horizontal plane. Let's say the tower is AB and is surmounted by a vertical flagstaff of height h. तो बेटा इस टावर के ऊपर जो है एक छोटा सा फ्लैग लगा देते हैं और इस फ्लैग की हाइट जो है दैट इज h meters is here. At a point on the plane, the angles of elevation of bottom and top of the flagstaff. तो बेटा ये जो पॉइंट है, बॉटम इज ए, टॉप इज क्यू, इनका एंगल ऑफ एलिवेशन फ्रॉम एनी पॉइंट ए ऑन द ग्राउंड इज अल्फा एंड बीटा. So let's say the point is P, its angle of elevation from A is given as alpha, and from Q, that is top of the flag, is given as beta. You have to prove that height of the tower is AB. So basically you have to find AB, or you have to prove AB is equals to h times tan alpha upon tan beta minus tan alpha. Let's see the solution. So in this we have been given AB is the tower and QA is the flag surmounted on top of it, and P is the point of observation, and your angle APB is alpha and angle QPB is beta. You have to prove that height of tower or AB is h times tan alpha upon tan beta minus tan alpha. That's the प्रूफ. अरे कहानी तो वापस वही चालू है. क्या कहानी है हमारे पास? दो राइट एंगल ट्राइंगल होंगे. उन दो राइट एंगल ट्राइंगल में यू हैव टू फाइंड द जो आपका गिवन डाटा है दैट यू हैव टू यूज एंड यू हैव टू फाइंड व्हाट इज आस्क्ड हियर. सो बेटा जो ट्रिग्नोमेट्रिक रेशियोज आप लेंगे उसमें ए बी जो है वो इंक्लूड होना चाहिए, है ना, क्योंकि ए बी इज व्हाट यू हैव टू फाइंड. ऑल्सो इन दोनों ट्राइंगल में जो APB है और QPB है, इन दोनों ट्रायंगल में PB जो है वो कॉमन है. तो आप कौन सी रेशियो लेंगे? 10 रेशियो, है ना, और उसमें फिर PB को आप एलिमिनेट कर दें, यू विल गेट योर आंसर. सो लेट्स सी द प्रूफ. सो लेट्स टेक द ट्रायंगल APB फर्स्ट. सो इन ट्रायंगल PAB tan alpha is perpendicular upon base और AB upon PB, राइट. सो यहाँ पर जो PB की वैल्यू है दैट इज AB upon tan alpha. ठीक है. तो अब जो हम ट्राइंगल लेंगे दैट ट्राइंगल विल बी QPB एंड उसमें QPB में हमारे पास PB जो है विल यूज दिस वैल्यू इन दैट. सो लेट्स टेक द नेक्स्ट ट्राइंगल दैट इज QPB. सो इन दैट tan beta is QB upon PB. ठीक है, परपेंडिकुलर अपॉन बेस. So QB is nothing but H plus AB. So and what is value of PB? PB is nothing but AB upon tan alpha. So let's replace these two values. You will get tan beta is H plus AB, that is QB upon PB. और PB की हमने ये वाली वैल्यू जो है बेटा PB की जगह पर डाली है ना. तो दैट्स इट. हमारे पास अभी सारी चीज़ें आ गई हैं. हमें इसमें सिंप्लीफाई करना है टू गेट द वैल्यू ऑफ ए बी. तो आई हैव डन क्रॉस मल्टीप्लिकेशन और यहाँ पर डिनोमिनेटर का जो tan अल्फा है वो ऊपर चला गया आपका, है ना. सिंप्लीफाई करेंगे एंड यू विल गेट वैल्यू ऑफ ए बी एज h tan alpha upon tan beta minus tan alpha. So we have got our height of tower and hence proved. Let's check the question. From the top of tower h meter high. So let's draw the ground and a tower which is h meter high. Angle of depression of two objects. So we are talking angle of depression. So the observer is standing at point A. Let's draw the line of sight for the observer. From here it is he is observing two objects which are in line with the foot of the tower. So those objects are on the ground and their angle of depression is alpha and beta degrees, where beta is more than alpha. So if beta is more than alpha, that means the observer with beta depression is standing closer to the tower. So let's draw this first. The observer who is closer is Q and its angle of depression is beta degrees. Now if you will see, these two lines are parallel to each other and thus by alternate interior angles, angle EQB, that will also be beta degrees. Let's take the second observer. For him the angle of depression is alpha. So the second observer is P with angle of depression is alpha. By same logic, alternate interior angles. So this angle and these angles will be equal, or angle APQ is also alpha degree. You have to prove that the distance between the two objects, that means the distance between PQ is H cot alpha minus cos beta. Let's see the solution. See the solution. So here it's given that AB is your tower and P and Q are the two objects whose angle of depression is taken. And for the first object Q, so MAQ is same as AQB is beta degrees. And for second object, angle MAP is same as angle APB is alpha degrees. And we have to prove that the distance between the object is, so distance between the object is PQ. So we have to prove that PQ is h times of cot alpha minus cos beta. Let's see the proof. So again वापस घूमकर हम वहीं पर आ गए, है ना. कहानी हमारी वही है कि दो राइट एंगल ट्राइंगल हैं बेटा हमारे पास, एंड इन टू राइट एंगल ट्राइंगल्स हमें पी क्यू निकालना है. तो बेसिकली ये एच गिवन है हमें, तो आप क्या करेंगे, आप क्यू बी निकालें, है ना, इस वाले ट्राइंगल में, फिर आप पी बी निकालें इन द अदर ट्राइंगल, दोनों को आप सब्ट्रैक्ट कर देंगे तो यू विल गेट वैल्यू ऑफ पी क्यू इन टर्म्स ऑफ एच, alpha and beta. So let's take our first triangle, that is triangle ABQ. So we'll take the ratio of tan beta is AB perpendicular upon QB. AB is H, so let's replace it and let's get the value of QB. QB is coming as H upon tan beta, है ना. अब कौन सी वैल्यू निकालेंगे, अब PB की वैल्यू निकालेंगे. तो उसके लिए हम ट्राइंगल लेंगे, ट्राइंगल ए बी पी, राइट एंगल ट्राइंगल है, कौन सी रेशो, tan alpha. Tan alpha is AB upon PB. AB is nothing but H, so tan alpha is H upon PB, and let's cross multiply to get value of PB as H upon tan alpha. लेकिन निकालना क्या हमें तो पी क्यू निकालना है. सो पी क्यू इज सेम एज पी बी माइनस क्यू बी, एंड लेट्स रिप्लेस दोज वैल्यूज. सो वी आर गेटिंग एच अपॉन टेन एल्फा माइनस एच अपॉन टेन बीटा, है ना. सॉल्व करेंगे तो यू विल गेट वैल्यू ऑफ पी क्यू एज एच टाइम्स कॉट एल्फा माइनस कॉट बीटा, एंड दस द डिस्टेंस इज एच टाइम्स कॉट एल्फा माइनस कॉस बीटा. And this is what we have to prove, and here comes our favorite part, that is hence proved. Let's check the question. So a ladder rests against a vertical wall at an inclination alpha to the horizontal. So we have ground, and on the ground you have got a wall is there. On this wall ladder is resting. So let's say our ladder is AB, it's resting and making inclination of alpha, that means the angle or point A is your alpha. Its foot is pulled away from the wall. तो बेटा लैडर का फुट कौन सा है, ये पॉइंट A है ना, इसको हम जो है पीछे की तरफ पुल अवे कर रहे हैं. इसको पीछे की तरफ पुल अवे करेंगे तो ये B जो है ये नीचे की तरफ फॉल करेगा, ठीक है. सो इट्स फुट इज पुल्ड अवे फ्रॉम द वॉल थ्रू अ डिस्टेंस P, सो दैट इट्स अपर एंड स्लाइड्स द डिस्टेंस Q डाउन द वॉल, ठीक है. तो लैडर को हमने जो पुल अवे किया तो A हैज गोन टू द पॉइंट C, AC is P and it has fallen down by a distance Q, so BD is Q, ठीक है. So BD is your how much it has fallen down, and AC is the foot which you have pulled away, है ना. So that AC is your P. Now then the ladder makes an angle beta to the horizontal. You have to show that, or you have to find the ratio of P by Q, or you have to show ratio of P by Q is cos beta minus cos alpha upon sin alpha minus sin beta. Let's see the solution. So it is given to us that OB is wall and AB is the ladder. Also CD is representing the same ladder but in the second position, or we can say AB is equals to CD. Also it's given that AC is horizontal slip, that is P, BD is vertical slip of the ladder, that is Q, angle BAO is alpha and angle DCO is beta. To prove that ratio of P by Q equals to cos beta minus cos alpha upon sin alpha minus sin beta. This is slightly lengthy question, so we will need space. So let's shift this to proof part on the side, so we'll get more lines or more space. Let's see the proof now. So we'll take, of course we have got two right angle triangles are there, so we'll use those two right angle triangles. One is COD and another is ABO. Now if you'll see in a generic approach, in our proving questions we have sin alpha, sin beta, cos alpha. So we are going to need those ratios, right? We have to find those ratios first. So let's take a triangle AOB and I'm taking the ratio of sin first. So sin alpha is perpendicular upon hypotenuse, so BO upon AB. So let's replace the value of BO as Q plus DO, and let's simplify it to get value of DO as AB sin alpha minus Q. ठीक है ना। अब साइन अल्फा के साथ में यहाँ पर साइन बीटा की बात कर रहा है, तो साइन बीटा की अगर बात कर रहे हैं तो हमें दूसरा ट्राइंगल चाहिएगा। सो लेट्स टेक द सेकेंड ट्राइंगल COD और उसमें साइन बीटा की रेशियो फाइंड कर लेते हैं एक बार, है ना, परपेंडिकुलर अपॉन हाइपोटेन्यूज। सो यहाँ पर जो है विल रिप्लेस द वैल्यू ऑफ DO, तो ये जो आपका जो आपने DO की वैल्यू अभी निकाली थी, है ना, ये DO की वैल्यू हम यहाँ पर रिप्लेस कर देते हैं। सो विल गेट साइन बीटा इज AB साइन अल्फा माइनस Q अपॉन AB। ठीक है, क्रॉस मल्टीप्लाई करते हैं, थोड़ा सा सिंप्लीफाई करते हैं एंड यू विल गेट वैल्यू ऑफ Q एज AB इंटू साइन अल्फा माइनस साइन बीटा। तो अगर आप देखेंगे तो बेटा हमारे पास ये जो Q था, Q की वैल्यू आ गई है AB टाइम्स साइन अल्फा माइनस साइन बीटा। एग्जैक्टली सेम वे में हम P की वैल्यू निकालेंगे और फिर उन दोनों की रेशियो ले लेंगे। ठीक है जी, तो वापस, है ना, इस बार ट्राइंगल COD से पहले शुरू करते हैं एंड विल फाइंड वैल्यू ऑफ, इंस्टेड ऑफ साइन नाउ विल प्ले विद कॉस। तो कॉस बीटा इज CO अपॉन और बेस अपॉन हाइपोटेन्यूज। CO को रिप्लेस करेंगे P प्लस AO से, सो कॉस बीटा इज P प्लस AO, है ना। यहाँ पर देखेंगे तो CO की वैल्यू जो है दैट इज P प्लस AO। थोड़ा सा सिंप्लीफाई करते हैं, ऊपर हमने DO की वैल्यू निकाली थी, यहाँ पर हम AO की वैल्यू निकालेंगे। ठीक है, तो सिंप्लीफाई करेंगे तो विल गेट AO एज AB cos बीटा माइनस P। तो अब कौन सा ट्राइंगल, यस विल टेक द ट्राइंगल AOB अगेन। ठीक है जी, ट्राइंगल AOB में कौन सी रेशियो, अभी यहाँ पर देखो सारी हो गई है, कॉस अल्फा रह गई है बस, तो कॉस अल्फा ले लेते हैं। तो कॉस अल्फा इज बेस अपॉन हाइपोटेन्यूज, है ना। एग्जैक्टली देखो सेम वे में प्रोसीड हो रहा है, ओनली थिंग इज कि यहाँ पर ये जो हमारे पास AO है इसकी वैल्यू हम यहाँ से रिप्लेस कर देंगे। तो वी आर गेटिंग कॉस अल्फा इज AB cos बीटा माइनस P अपॉन AB। अब यहाँ पर आप क्रॉस मल्टीप्लाई करेंगे, AB विल गो ऑन अदर साइड, सो इट बिकम्स AB cos अल्फा एंड देन यू टेक जो AB वाली टर्म्स है ऑन वन साइड, है ना। तो सिंप्लीफाई करके व्हाट यू विल गेट इज योर P इज इक्वल्स टू AB टाइम्स cos बीटा माइनस cos अल्फा। तो बेटा आपके पास P की वैल्यू आ गई है और Q की वैल्यू आ गई है, और चाहिए कि आपको P अपॉन Q, तो दैट्स इट। इसको आप 1 और 2 मार्क करें, डिवाइडिंग 2 by 1 you will get the ratio of P by Q is cos beta minus cos alpha upon sin alpha minus sin beta, and that's what we had to find, and hence proved, our favorite part. Let's see the next question. So we have a window of a house is h meter above the ground. So let's draw the ground and then the building with window W. Right, from this window the angles of elevation and depression of top and bottom of another house is found to be alpha and beta. So let's draw the other house. So that other house is OQ, and the angle of elevation and depression, for that we need line of sight. So observer is at W, and let's draw the line of sight. From here the angle of elevation is alpha, so this angle is alpha, and angle of depression to the bottom, that's beta. You have to prove that the height of house is h times 1 plus tan alpha cot beta, or basically you have to find the height of the house, or QO. QO is what you have to find. But here if you will see, MO is same as WB, so MO is also h meters, or in one word you have to find QM and then you add h into it to get the height of house. Let's see the solution. So here in this question given is the height of smaller house is WB and the other house is represented by OQ. W is point of observation, that's the window of smaller building, and QWM, that's angle of elevation, is given as alpha, and angle MWO, that's given as beta. We have to prove the height of house, that is QO, that full house is h times 1 plus tan alpha cot beta. And let's see the proof of this. So here if you will see, again we have got two triangles are there, right? The two triangles are your WQM and WMO. These are the two right angle triangles are there, so in which you will use trigonometric identity, and WM is common in both of them. So using this triangle first, we'll find out what is the value of WM in terms of h and beta. Once we have got WM with us, so we'll use this triangle and we'll get the value of QM in terms of alpha and WM. So once you have got QM, we'll add h into it to get the value of QO. So let's take the triangle WMO first. So in triangle WMO, tan beta is perpendicular upon base, or MO upon WM, and putting MO as h, we get tan beta is h upon WM, and from here we'll get the value of WM as h upon tan beta. Now this value of WM we'll use in this second triangle. So in triangle WMQ, let's take tan beta, that's perpendicular upon base. QM is what we have to find. So let's take QM is WM times tan alpha. Now this value of WM we will put here and we'll get QM is h upon tan beta into tan alpha, right? 1 upon tan beta is cot beta, so basically QM is h times cot beta tan alpha, but we don't have to find QM, right? We have to find value of full QO, or the building. So the value of QO is MO plus QM, and MO is h, QM we have just found. So adding these two, we'll get our result, that is the height of the building is h times 1 plus tan alpha cot beta, and that's what we had to prove, and hence proved. I hope you enjoyed the solution. Keep watching. See the question. So a spherical balloon of radius r subtends an angle of theta at the eye of an observer. So this balloon is given, and let's draw the ground with observer A on it. So this balloon is subtending an angle of theta at the eye of observer. So this angle is given as theta. OQ and AP, they are the tangent to the circle. If the angle of elevation to its center is phi, so here O is the center and angle of elevation, so if I'll join the line from A to O, so this is angle of elevation which is given as phi. Prove that the height of the center, so the center is O, its height from the ground, that will be represented by line OB, and let's take this as h. So you have to prove that the value of h is r times sine phi times cosec theta by 2. Let's see the solution. So here what is given is, let's write it down first, that O is the center of balloon and OQ is the radius. Also point A is observer and angle PAQ and angle OAB, they are given. Next is the proof. You have to prove that h is equals to r times sine phi into cosec theta by 2. So like all other questions, so what we will be doing is, we will be proving it with the help of two right angle triangles. So here if you will see two right angle triangles, one is this triangle is there, that is triangle AOQ, and another is the triangle ABO is there, right? And both of them have got this side AO common between them. So we'll first solve this triangle and then we'll take this second triangle to get our answer. So let's take the triangle AOQ first, right? So in triangle OAQ you get sine theta by 2. Now if you will see this line AO, right? So by the theorem of circles, so this line AO is angular bisector for angle A. So this particular angle will be nothing but theta by 2. So sine theta by 2, in this triangle sine theta by 2 is perpendicular upon hypotenuse. So that will be OQ upon OA. OQ is given as the radius of the circle. So replacing it, will get sine theta by 2 equals to r upon OA, or we can say that OA is equals to r upon sine theta by 2, which is same as r times cosec theta by 2. So now we have got the value of OA, and in this second triangle we have been given this value of phi is given, and you can find the value of h, and that is what we have to find. So let's take the second triangle, triangle OAB. So in this triangle we are interested in OB, we have to find OA is given. So we'll again take the sine ratio. So we are getting sine phi is OB upon OA, which is same as h upon OA. So what is value of h? H is equals to OA times sine phi, and this value of OA we can put from here, right? So this value when we are putting here, we'll get our value of h. So h is coming as r times sine phi into cosec theta by 2, and this is what we have to prove, and hence proved. I hope you enjoyed the solution. Keep watching. Let's see the question. So the angle of elevation of a cloud from a point h meters above the surface of lake is theta. So we have got a lake is there and a cloud is there, and its angle of elevation is measured h meter above the surface. So let's say AB is the height h meter, and from point A the angle of elevation is measured. So from point A we'll first draw the line of sight, and then the angle of elevation, that's given as theta. And the second part is the angle of depression of its reflection in the lake. So reflection of the cloud is there, and this angle of depression for this from the same point A. So we'll draw the angle of depression. So this is the line joining it, and phi is the angle of depression which is given. You have to prove that the height of cloud above the lake is this. So for that we'll join the cloud and its reflection, and here this line is perpendicular to the line of sight, and you have to find the height of the cloud. So here the height of the cloud is Pn. Let's take it as x, and by the property of reflection nq will also be x. So we have to prove that x is equals to h times of tan phi plus tan theta upon tan phi minus tan theta. Let's see the solution. So here what is given is that P is the cloud and point Q is its reflection in the lake, A is the point of observation, and AB is H, angle PAL, that's angle of elevation, is theta, angle LAQ, that's angle of depression, which is phi. Here we have to prove that the height of the cloud is h tan phi plus tan theta upon tan phi minus tan theta. Let's see the proof of it. So let the height of the cloud above the lake is x. So here if you will see, again we have got two triangles are there, right? Two right angle triangles, and you have to use these two triangles to get the value of x. So these two triangles are there, and you have got something common between them, that is AL is common between them. So we'll first take the triangle APL. Here AL is unknown, but this PL is nothing but x minus ln, and ln is same as h. So basically your PL will be x minus h. So in this triangle we'll find the value of AL in terms of theta and x minus h. Same way the second triangle we'll use is triangle ALQ. Now in this triangle ALQ, this QL is given as x minus x plus h, right? And AL is unknown. So both the triangles, in both the triangles we have got these angles are there, and the sides are given. AL is unknown, and this AL is what we will compare to get the value of x in terms of h. So let's take our first triangle. So the first triangle we are taking is triangle ALP. So we'll use tan theta. So tan theta is perpendicular upon base. Here the value of PL, that is x minus h. So we'll put that value. So we'll get tan theta is x minus h upon AL. And let's find the value of AL in this. So AL is coming as x minus h upon tan theta, right? Now in this second triangle AL is known, right? AL is known, LQ is known, that is x plus h, and we'll compare, we'll find the value of tan phi. So second triangle I am taking is triangle ALQ. In that tan phi is equals to perpendicular upon base. Let's put value of LQ. LQ is nothing but x plus h, and in this let's put the value of AL, right? We have got this value of AL with us. Let's put this value here. So we are getting tan phi is equals to x plus h upon x minus h upon tan theta. So simplifying it, we'll get x minus h times tan phi is equals to tan theta into x plus h. Let's take the terms with x on one side and terms with h on other side, right? So simplifying it, we'll get value of x as h times tan phi plus tan theta upon tan phi minus tan theta, and that's the height of cloud, and that's our answer, and hence proved. I hope you enjoyed the solution. Keep watching.